Welcome to Lecture Online, and our next topic in thermodynamics is heat transfer. Now that's a big topic, and what we're going to do here is talk about some basic definition, basic terminology, and hopefully gain some basic understanding of what heat transfer is. Now in nature there are three main ways in which heat can be transferred. One is called conduction, the other one is called convection, and the third one is called radiation, and all three occur in nature at all times. Now, conduction is a method by which the heat travels along a medium. Everything stays in place. Let's say we have some hot object and some cold object and some path in between, a physical path that doesn't move, doesn't change. And so what we expect is that heat would be traveling from the hot object to the cold object through that medium. So it's actually taking a road, a path on that medium. Convection is a means by which heat is transferred through the movement of a medium. For example, we have a hot object in a room. It heats the air up around it. The air will then move, expand, and tends to move, and the heat will then travel along with the hot air, typically hit the ceiling, come around, then come down and heat a person on the other side of the room by having warm air move towards that person. So here the heat takes a ride on the medium. It's the medium that moves and the heat just comes along for the ride. The third method doesn't need a medium at all. It doesn't need a path. It doesn't need something that it can go piggyback along. Radiation is just the means by which heat moves from one point in space to another point in space, and there doesn't have to be anything in between. Now, there is space in between, and space is something, but again, we think of space as a vacuum that doesn't have any atoms within it. And so when heat radiates out from a hot object, it goes in all directions, tends to go out at the speed of light. It's electromagnetic radiation, in essence, that moves out. And if you place two objects together, a hot object and a cold object, we will learn later that the hot object radiates way more heat and therefore cools down. A cold object will also radiate out heat and also cool down. However, if it's placed in the presence of hot objects, it will receive the radiation from the hot object, which tends to increase its temperature. And likewise, the hot object will receive radiation from the cold object, which would tend to increase the temperature. However, since the hot object is radiating out more heat than it's receiving, the net result is that the temperature will go down for the hot object. Since the cold object is receiving more heat than it's radiating out, it will tend to rise in temperature. And again, as you will see in all three methods, conduction, convection, or radiation, heat will be transferred in such a way that hot objects will tend to cool down and cold objects tend to heat up until everything tends to be in thermal equilibrium. So that's usually the end result, or at least the end goal in nature, of heat transfer. So we'll talk about the specifics a little bit more, but for conduction, the way heat travels across a conductor or a heat conductor is the physical motion of the atoms. The vibration will be transferred to the molecules next to it. They will begin to vibrate more and it will be transferred. So if the vibrational mode of the hot object can be transferred through a pad, we then say that that pad is a heat conductor. In convection, it's simply that the air molecules are moving. It could also be water molecules or any kind of fluid. And so as the molecules are being heated by some hot object, they then move and the heat then transfers along with it. In the case of radiation, it comes from the atoms within the object vibrating back and forth. Since there are associated electric fields with the vibrating atoms and molecules, those electric fields then will oscillate back and forth, which causes electromagnetic radiation to expand and not expand, but to radiate away. And so the amount of radiation does depend upon the temperature, and the hotter it is, the more they radiate, the colder it is, the less they radiate, and so there tends to be an equilibrium that's eventually reached. So that's the basics of heat transfer, and in the next several videos we'll talk a little bit more about the details of each and how to calculate the actual amount of heat being transferred via those three methods.